Hello, welcome to Twitter Think, and in today's video we are gonna differentiate the following functions we have here: root of x, 1 out of x squared, x 5 over 3, 1 out of cube root of x. So anytime we have a function of this form, how do we differentiate it? We need to know that functions of this form, we need to apply basic rules in indices. So let's box on, let's tackle the first one. So for the first example, we have root of x, but we need to differentiate the function in terms of y and x. So changing y and changing x. So all we need to do is to name the function and let it be equal to y. So we say that for our first step, let y be equal to root of x. Now in indices, root of x is the same as x raised to the power 1 out of 2. We all know that, so we will apply that by rewriting the function y equal to x raised to the power 1 out of 2. Now it's very simple for me to differentiate. So I'm differentiating y with respect to x, and I'm having dy dx being equal to 1 out of 2 times x, 1 out of 2 minus 1. So you multiply the exponent or the power by the variable and you reduce the power by 1. So when I reduce it by 1 or I subtract 1 from it, that is the result I'm getting. So now when we subtract this, we are getting dy dx being equal to 1 out of 2 x raised to the power negative 1 out of 2. So you can punch this side on the calculator. Now we need to rewrite. I will take you back to indices again. In indices, there is a rule that says that if I have x raised to the power negative 1 is the same as 1 out of x, and when I have x raised to the power negative 2 is the same as 1 out of x squared. Then in the same way, if I have x raised to the power negative half, then I'll get 1 out of x raised to the power half. And half is the same as square root, giving me 1 out of root of x. So do not be confused when I apply that. So here my dy dx will be equal to 1 out of 2, 1 out of 1 over 2. So this is giving us dy dx being equal to 1 out of 2, 1 over root of x. So we can now multiply this 1 times 1, 2 times this. So dy out of dx equals 1 out of 2 root x. So that is the solution or the answer for the first question. Let's move on to the next question. The next question says we should find the derivative of x raised to the power 5 out of 3. So now this is what we are supposed to work on. So we say that let the function, let y be equal to the function. So we have x 5 out of 3. So now when I differentiate this, I'm getting dy dx being equal to 5 out of 3 times x raised to the power 5 out of 3 minus 1. You reduce the power by 1, use the power to multiply the variable x. So this is giving us dy dx being equal to 5 out of 3 times x raised to the power 2 out of 3. You can punch this side on your calculator to produce your final answer. So this is going to give us dy dx being equal to 5 out of 3 multiplying x all squared times 1 out of 3. I want to change this thing to indices. When I multiply this by 1, I'll get the same 2 out of 3. And 1 out of 3 is the same as the cube root of what? X. So I can rewrite the final answer as dy dx being equal to 5 out of 3 cube root of x all squared. So I can rechange the thing back to this side. So this will be my final answer for this question. Then we move on to the third one, which is 1 out of x squared. So my third example, 1 out of x squared. So for this, we know from here that when we have x raised to the power minus 1 over 2 is the same as this. So we can rewrite it that this is the same as x raised to the power minus 2. So let y be equal to x raised to the power minus 2. So derivative of this will give me dy dx being equal to minus 2 x raised to the power minus 2, then we reduce the power by 1 minus 1. So this is giving us dy dx being equal to minus 2 x raised to the power minus 3. X raised to the power minus 4. That was a mistake, so x raised to the power minus 3. So if I have x raised to the power minus 3 is the same as 1 out of x cubed. So I'm getting dy out of dx being equal to minus 2 1 out of x all cubed. And that will be my final answer. I can multiply this by this to give me, this is a whole number, so a whole number is always over 1, so the denominator 1 will multiply this will multiply the numerator. So we have dy out of dx being equal to minus 2 over x raised to the power 3. And this will be our final answer for this one. We move on to, this is the final answer. We move on to the last example. The last example, the question was 1 out of cube root of x. So we say that this is the same as 1 out of x raised to the power 1 over 3. Cube root of x is the same as this. So I can now name the function that let y be equal to 1 out of x, 1 out of 3. And anytime if I have x raised to the power 1 out of 3, 1 here, I can use indices to say that if I have 1 out of x, which is equal to minus x raised to the power minus 1, then if I have 1 out of x 1 over 3, then I can have x negative 1 out of 3. So this is the same as this. So I can apply it here by saying therefore my y equals x raised to the power negative 1 out of 3. Then we can now differentiate by saying dy out of dx equals negative 1 out of 3 x raised to the power negative 1 out of 3 minus 1. So we reduce the power by 1, and we have dy out of dx being equal to minus 1 out of 3 x. You can punch this side on the calculator, giving us supposed to be negative 4 out of 3. So we need to rewrite this negative 4 out of 3. We need to rewrite this by removing the negative here. So we have dy dx being equal to negative 1 out of 3 multiplying 1 out of x raised to the power 4 over 3. Then if so, we can say that dy out of dx, we are now coming to apply another principle. I want to write it on the plain sheet first. So if I have something like 1 out of x raised to the power 4 out of 3, then I can use indices to say is the same as 1 out of x. I can factorize raise to the power 4, multiply it by the cube root, so that we know this is over 1, so that this time this will give me 4, and 1 times 3 will give me the same as 3, giving us 4 out of 3. So this becomes the cube root, and the final answer becomes 1 out of cube root of x raised to the power 4. So that is what we apply here. Negative 1 out of 3 multiplying 1 out of cube root of x raised to the power 4. So we have dy out of dx being equal to negative 1 out of 3. I want to write this again. 1 out of cube root of x raised to the power 4. Now we can multiply this by getting dy dx being equal to negative 1 times 1 will give me negative 1 all over 3 cube root of x raised to the power 4. And this will be our final answer. So this is how we use the indices to differentiate functions of this form. It is very simple. We need to know how to manipulate indices. The basic rules of indices you can read under indices and logarithms to learn the rules to make it easier for you to differentiate functions of this form. My name is Daniel. If this video was helpful, kindly subscribe to this channel and watch out for more updates.